Hello everyone, my name is Raina Dechute and welcome to my Module 13 LeetCode problem solving video. In this video I work through 5 SQL problems and we're going to walk through each one, but the focus is the reasoning and not the actual query itself. These all come down to relational thinking, how you join tables, groups, rows, and rank results. That's the same kind of thinking behind the Rocket Food Delivery app, where orders link to customers and products link to restaurants and so on and so forth. So without further ado, let's jump into the first one, which is Nth Highest Salary. So in this problem, I had to write a function that returns the nth highest distinct salary. The key is this limit m, 1. In MySQL, that means we skip m number of rows, then I take 1. So I sort the distinct salaries from highest to lowest, and then I get the nth one. I skip the first n minus 1, and then I grab the next. And if there aren't enough salaries, then it will just return null, which is what is expected. And with this limit m, 1, in MySQL, limit offset count skips offset rows and then takes count rows. To get the nth highest, I sort distinct salaries from highest to lowest and then skip the first n minus 1. So for the second highest, I skip 1 and take 1. I use distinct because two people can have the same salary, but that's still one salary rank. And then we compute m equals n minus 1 in a variable because limit won't accept an expression like n minus 1 directly. If there aren't enough distinct salaries, the subquery returns nothing, which becomes null, which is exactly what the problem wants. So moving on to the second problem, which is department highest salary. So in this problem, I need the top earner in each department. So my subquery groups by departments and then takes the max salary, which gives me the winning salary. So there's two pieces of this. First, the subquery finds the top salary per department, which is this group by department ID, and then maxed salary. That gives me a list of department and winning salary pairs. Then the outer query keeps the only employee whose department and salary is in that list. The reason we match on the pair department and salary instead of just salary is that a high salary in one department might not be the top in another. The department has to match too. And in using the in instead of a join here naturally handles ties. So if two people tie for the top in a department, both pairs match, so both show up. And then our third problem is rank scores. So this problem is asking us to rank everyone highest to lowest, ties share a rank, and there can't be any gaps in the numbering. This is the type of problem that window functions were built for. So dense rank assigns a rank based on the order by inside of the over clause. So here score is descending. The reason it's dense rank and not just regular rank is the no gaps rule. So if two scores tie for the first, regular rank would skip over first two and reach the third next, but dense rank continues at second. I also have to wrap this rank in backticks because it's a reserved keyword in MySQL. The fourth problem is rising temperature. This problem is saying that I need days that were warmer than the day right before. So the tricky part of this is that I'm comparing a row to a different row. So I join the table to itself. One copy is today and then the other copy is yesterday. And in the code and in the query, this W1 is today and W2 is yesterday. And we only keep this date diff, W1 and W2 equals 1, keeps only the pairs that are exactly 1 day apart, just in the event that some dates are missing. Then we keep the pairs where today's temperature is higher than yesterday's. And then our last problem is consecutive numbers. So this has the same self-join idea as the last problem that we did, but in this problem we make 3 copies instead of 2. So what this problem is asking is I need numbers that show up 3 times in a row. So we line up 3 consecutive rows by ID, L1, L2, and L3. But we line them up 1 ID ahead of each other. So L2 is 1 ID ahead of L1, and L3 is 2 IDs ahead of L1. The join conditions, which is this LID equals L2 ID minus 1 and LID equals L3 ID minus 2, are what stack them in order. Then we keep only the triples where all three of the num values are equal. That's the same number 3 times in a row. And then we have this select distinct here, because if a number repeats 4 or 5 times, multiple overlapping triples will match. So we've got the first 3, then the middle 3, and then we've got the last 3. And we only want to report that number 1 time. So that's the problem solving and reasoning behind all 5 of these problems. The thread that runs through all of these problems and relates them is this relational reasoning. So using distinct and limit to pick a ranked row, grouping to find a max per category, window functions for ranking, and self-joins to compare a row against another row. These are the same tools behind any real relational database, including the one my food delivery app from Module 13 runs on. So that's all I have for this video. Thank you for watching, and I will see you on the next one.